All right, in the last video, we talked about over and underestimating. We can see from the curvature whether we're over or underestimating. If a tangent line is above the curve, which would happen with concave down, it's an overestimate because the tangent line is above the curve. And in contrast, the tangent line would be below the curve when the curve is concave up, creating an underestimate. Let's go over an example. And I am going to use my calculator to quicken up some of the examples. So just have that handy if you want to do that yourself. All right, 43 degrees. We're going to do approximate tangent of 43 degrees using linearization. That's another way to ask you to do a linear approximation. And then we'll be talking about the error as an under or over estimate. All right, to do that. All right. Before I begin, I do note this is in degrees and we do everything in radians, right? So I'm going to do a quick conversion. 43 degrees is to 180 degrees as some angle theta, I'll just call it theta and make it easy, is to pi, because 180 and pi are equivalent. And if I multiply both sides by pi, I will get my theta, which is equal to 43 pi over 180. So there's my quick conversion. All right, remember this is going to be, this is what I'm trying to approximate. So in the end, we're going to try and approximate the tangent of 43 degrees in the form of 43 pi over 180. All right, and I will be doing that using a linear approximation. So some function L of x, okay? So we'll calculate that in a moment. So to do this linear approximation, I am going to need to know the y value for my linear approximation. So first, using this 43 degrees, what is a good point of tangency, right? That's what we're trying to figure out is what is the point of tangency so I can create this linear approximation. Well, this is very close to 45 degrees. So it's probably smart to use the point of tangency to be 45 degrees. But again, I need radian mode, and that's going to be pi over 4. So now I need the function. My function will be the tangent function. And I'm going to now calculate. So I need to do f of pi over 4 plus f prime at pi over 4 times x minus pi over 4. That's going to be my tangent line. All right, so f of pi over 4. So that's tangent of pi over 4. Tangent of pi over 4 is 1. Okay, so that part is done. Plus, now I need the slope, tangent slope at pi over 4. So let's take the derivative. Okay, derivative of tangent is secant squared. So I'm going to write that as secant of x quantity squared. And then I evaluate that at pi over 4. So secant of pi over 4, and then I square that number. All right, secant is the reciprocal of cosine. So cosine of pi over 4 is 1 over rad 2. Flip it, rad 2, square rad 2, I get 2. So this is going to be square root of rad 2 squared, which is 2. Okay, so that is going to be my tangent slope, so plus 2 times x minus pi over 4. All done with that. So there's my tangent line approximation. And now we're going to plug in that 43 degrees, 43 pi over 180. Wherever the x is, that's where it goes. I'll move this over a little bit. Okay, so 43 pi over 180. Pi over 180, and then minus that a, which is pi over 4. All right, so now calculating this by hand is a little bit tricky, right? These are kind of tough numbers. So this is where I said I'm going to cheat a little bit and put this on the calculator. And so for this, we got, oops, gotta look it up. And 0.93, 0.9302. And I do want to compare it real quick with the tangent, so the actual value. So you put this on your calculator, make sure you're in radian mode. And this comes out to be 0.9325. And so you can see that there are two places up to the 100th place where we have their exact match. So there's our level of accuracy to 2 decimal places. That's not bad. Our error would be the positive difference between those two numbers. So 0.9325. Since it's an absolute value, we don't care about the order of subtraction. And so that difference is 0.0023. And so you can see those 2 places of accuracy in the error. Is this an over or underestimate? If I make a quick sketch of my tangent curve, and let's see, so let me see if I can kind of sketch. Oops, I don't want to use the linear. Let me take off my line. Okay, so there's a point at pi over 4, so that's pi over 4, comma 1. And it passes through the origin, and then it's at negative pi over 4, comma negative 1. There's a point, and it has that curvature. Whoops. I always do better on the left than I do on the right. Don't forget there's that asymptote at pi over 2. Okay, so we can see that the curvature is concave on the right side of the graph. We're estimating near pi over 4. So let's go ahead and put that tangent segment in there. So at pi over 4, there's this tangent segment at that point. And since we have that concave up shape on the right side of the y-axis, that tangent line falls below the curve. And so our estimate is an underestimate. So concave up in the region that we're looking at, the other side is concave down, but this turns to concave up. And so that implies that we have an underestimate from our linear approximation. And there's another way to tell, right? So take a look at our numbers. The linear approximation is 9.9302, and the actual or calculator approximation is 0.9325, which is more. So the linear approximation is under that value. So there's 2 ways to get that. All right, let's take a look at another example real quick. Here is a function, cube root, has a cube root in it and an x squared, and we're going to approximate the value of negative 8.01. Okay, so I would encourage you to pause the video and work this yourself. And I'm going to continue from here. All right, so since I'm taking a cube root, and I don't know the cube root of negative 8.01 without my calculator. So I'm going to choose negative 8, which I can cube root. So that was going to be where my tangent point will be, at negative 8. All right, and so that means I need to calculate f of negative 8, which means I'm taking the cube root of negative 8, and then I'm squaring negative 8. So that would be negative 2 plus 64, and that is 62. Okay, good. Now we're going to do f prime of x so we can get the tangent slope at negative 8. All right, so this is x to the 1/3. So if I take a derivative of that, I get 1/3 x to the minus 2/3. And the derivative of x squared is 2x. Let me rewrite that for a little simplicity. That's 1/3. Well, x to the 2/3, but I'm going to write that as the cube root of x That's the 1/3 part. And then I square it. That's the 2 part, right? And then the minus, we just moved it down. And then plus 2x. And now I'm going to evaluate. I want to know what my tangent slope is. So I evaluate that at the point of tangency. All right, what is the cube root of -8? Isn't that -2? And then I don't want to forget, I still have to square it. I haven't done that part. And then I'm doing 2 times -8. Okay, so that -2 came from doing the cube root of -8. All right, this is 1 over 3 times 4. That's 1/12. And then minus 16. And I'm just going to put this on the calculator, and I get negative 191 over 12. All right, so there it is. All right, so recall what we're doing. We're trying to figure out what f of -8.01 is. We're going to use our linear approximation to do so. So that would be L of -8.01. Okay, so how do I get that? All right, that's going to be my y value, f of -8, 62, plus the tangent slope, -191 over 12 times, and then I put my value here, and then I subtract my a, which is -8. All right, so this value, -8.01. All right, so this was f of -8. This is f prime of -8, and here's -8. And so I put all this on my calculator, not forgetting that we have some double negatives, plus, right? Do all that. Okay. All right, so I put that on the calculator, and I get, what did I get? This, I'm blanking out. I got 62.159. All right. And then it asks you to verify whether it's concave up or to, what is it, overestimate or underestimate. If you do a quick sketch on your calculator of this function, you get an interesting curve. It kind of looks like this. Something like that. And at -8, we are, so if this is maybe -8 right here. This is a concave up section. So the curve is, the tangent line is under, and therefore this is an underestimate once again. Okay, I didn't calculate f of -8.8. Go ahead and evaluate that, and you should see that that number should be below this one. Okay, that's it. Let's get to practice.